Hi there, my name is Gilbert Ronald Gomez, and this is the 5% presentation of the Communication Networks course, Term 6. So, for my presentation, the topic is subnet mask. So, I'm gonna first of all describe what exactly is a subnet mask and then move on to its purpose and use. After that, I will explain an example of subnet mask and thus ending the presentation with some benefits of using subnet masks. So let's start. So what is a subnet mask? A subnet mask can be described as a 32-bit number used in IP networking to provide an IP address into two components, which are the network part and the host part. A subnet mask determines which portion of the IP address identifies the network and which portion identifies individual devices within that network. Subnet masks are typically expressed in decimal format like 255.255.255.0. Here, each 255 represents 8 bits set to 1, and each 0 represents 8 bits set to 0. So basically, this whole thing can be written as 8 ones dot 8 ones dot 8 ones dot 8 zeros. Moreover, the subnet mask works in conjunction with the IP address to create subnetworks, which allows the organizations to efficiently manage and utilize IP addresses. Moving on to its purpose and use of subnet masks. So why use subnet masks? Subnet masks are crucial for a variety of purposes. They often provide several critical roles in network communications, such as network identification, routing efficiency, segmentation, which is basically reducing the network congestion, and security. It enhances the security by isolating the networks. So in terms of network identification, subnet masks help to distinguish the network portion of an IP address from the host portion. Whereas in routing efficiency, subnetting minimizes traffic by ensuring that packets are sent only to the relevant subnet rather than to all the devices in a larger network. In segmentation, subnets allows organizations to divide their networks into smaller manageable segments, thus making life easier. In terms of security, subnets help isolate parts of a network, thus limiting access and potential damage in case of an attack. So now I'm gonna give a basic example of subnet masks. So let's consider this particular example. Here we have an IP address 192.168.1.10, and the subnet mask, the relevant subnet mask for this IP address is 255.255.255.0. So you might be wondering how we got the network address 192.168.1.0, but here the IP address was, the last digit was 10, but here it's 0. You might be wondering how is that case. So basically the subnet mask indicates that the first 3 octets, which are 192, 168 and 1, represents the network, and the last octet 10 represents the host. Therefore the network address is 192.168.1.0. That's this part. So when the device sends data, the subnet mask helps to determine whether the destination is within the same subnet or a different one. If the destination is in a different subnet, the data is routed through a gateway. So digging into a more detailed description of the example. So basically, we have to perform a binary AND in order to get the subnet address. The binary AND operation between these two addresses. So in order to do that, we have to first convert every decimal. So as you can see, like, these addresses are given in decimal format, so we have to convert it into binary form. So after doing that, we will just perform a simple binary AND operation in between each respective parts of the address. For example, 192 ended with 255, 168 ended with 255, 1 ended with 255, and 10 ended with 0. So the address, the result we get will be this: 192.168.1.0. This will be the address, and that's it. So that's the network address. So this network address represents all devices within the same subnet. Any IP address within this subnet will share the same network portion, which is 192.168.1, but have a unique host portion. Example, it can be 1, 2, 3, 4, 10, etc. With the subnet masks of 255.255.255.0, the last octet 8 bits is reserved for host. This means the first usable address will be 192.168.1.1, and this is basically used for devices like computers or routers. The last usable address will be 192.168.1.254. As you can see, the highest limit is 255 of any part of the address. The highest limit is 255. So the first for the first usable address, the last part will be 1, and the last usable address, the last part will be 254. This is because the address in where the last digit will be 255, that is the broadcast address. So basically, the broadcast address for this subnet is 192.168.1.255. And that's all for the example. So moving on to the last segment of this presentation, benefits of using subnet masks. So what are some benefits of using subnet masks? We have seen that it provides a great deal of operation to make things easier for many devices such as computers and routers. So let's talk about some benefits. So subnet masks are very efficient in terms of allocating the IP addresses, which is basically that it reduces waste by allowing organizations to allocate smaller subnets for specific needs, thus conserving addresses for larger networks. Next, we can see that subnet masks provide improved network performance. This is because subnetting limits the size of each subnet. Therefore, the overall broadcast domain is reduced, which decreases the unnecessary traffic. Next, we can see that enhanced network security. So subnets can isolate sensitive areas of a network, making it harder for unauthorized users to access them. So basically, we can see that it provides a great deal of security. So there's no risk of any hacking or any kind of those stuff. Next, we can see that it provides a simplified network management. Subnet masks divide a large network into smaller parts called subnets. Thus, it makes it easier to troubleshoot, manage, and maintain. So that will be it. That's basically it for my presentation. I hope you enjoyed and I hope you learned something. I hope you have a great day. See you soon. Thank you.